All right, in this video I'm going to cover reflections, similar to how I covered translations before in a previous video. This is intended just to be an overview and a reminder of what reflections are, the way we can describe reflections in words, using graphs, and using algebraic rules. Okay, so reflections can be described as a flip across a line. So we're going to say we're going to flip an image. In this case, we're going to reflect across the y-axis for this example. So my first step is to always draw my line of symmetry in, or the line of reflection, so that I can identify where that is, and essentially in my mind where I'm folding this graph, where it's going to fold in order to map the pre-image, which is triangle C, to its image, which will be C prime, D prime, E prime. All right, so in this case, what we're going to do is take each individual point to represent this reflection graphically and reflect it across this line of symmetry. So point C is 1, 2, 3, 4 units away from my y-axis, and so I need to go 4 units to the left, and we're going to call that C prime. D becomes E prime, and E becomes E prime. Now, what you're going to notice, if you connect any of these pre-image points with its image, if I connect any of those pre-image points with the image, it will always make a 90-degree angle with my line of symmetry. So notice all of these have to be 90-degree angles, and the two segments between the pre-image point and the line of reflection and the line of reflection in the image will create congruent segments. So I know I did it correctly because these lines are congruent, and each of the segments connecting the pre-image points and the image create 90-degree angles with my line of reflection. All right, last step is connect all of my vertices to create the shape, because I'm not actually moving just those 3 vertices. I'm moving every point of this triangle CDE to create triangle C prime, D prime, E prime. I can do that just by moving or transforming or reflecting the vertices and then connecting the dots, because all the other points reflect as well. Right, so the algebraic rules I'll go through quickly. These do not need to be memorized, at least in my class, and hopefully, I mean, if you want to take screenshots or notes on this as you watch, that's fine as well. What you're going to notice is that if you reflect any point across the y-axis, your y value will stay the same. Notice C has the same y value as C prime. My x values will turn to the opposite. So this is the rule for a reflection across the y-axis. There are 3 other ones that we should cover quickly. Reflection across x-axis, we'll go across the line y equals x, and across the line y equals negative x. So to draw what that looks like, across the x-axis, your reflection line will be a horizontal line, like so. Across the line y equals x will be a diagonal line where all your x and y values are going to be the same on a coordinate grid. And the line y equals negative x will be a reflection line where all your x and y values in a coordinate are opposites of each other. So it'll be diagonal 45 degrees to the coordinate plane. So I'll go through what those rules look like. So if we reflect across the x-axis, any point that you have will get transformed by keeping our x value the same in this case, but our y value will turn to be the opposite. What you'll notice if you reflect across the line y equals x is your x and y values will switch places in any coordinate. So your xy becomes yx. Like if I had 1, 2, the transformed point or reflected point would be 2, 1. And lastly, if I reflect across the line y equals negative x, you will see that your x and y values switch places in the coordinate, but they also change signs. All right, so I hope this helps. You'll have some matching exercises in the upcoming slides, and then a few where you need to actually reflect across the x and y axis. Good luck.